Today we're going to evaluate inverse trig functions. What we want to remember with inverse trig functions is the range of each, which you learned about in the previous video on the graphs of inverse trig functions. So we want to keep in mind that arcsine has a range from negative pi over 2 to pi over 2, including the endpoints. Arc cos has a range of 0 to pi, and then arctan has a range of negative pi over 2 to pi over 2, not including the endpoints. So be sure while you're doing these problems that all of this has been memorized. So let's start off with a problem like finding the value of arcsine of negative 1/2. Okay? What this is asking us to do is to find the angle whose sine is negative 1/2. So this is kind of backwards from what we've been doing the past few weeks, where before I would give you an angle and say find the sine of that angle, and you would tell me that it's negative 1/2. Now you're kind of given the answer and you have to figure out what the angle is. So let's start off with the range of arcsine. We know that the range of arcsine is negative pi over 2 to pi over 2. So our answer has to be between negative 90 degrees and 90 degrees. So let's take a look at where that might be. Here's negative 90, here's 90, and all of the angles in between, right? If we drew angles in between negative 90 degrees and positive 90 degrees, they would lie either in the first quadrant or the fourth quadrant. So I'm going to rule out these. These are gone. But we still have to narrow down between the first and the fourth quadrant. And the way we do that is we remember the signs. Okay? We know that all of our trig functions are positive in the first, and cosine is positive in the fourth. Now here we're being told that the sine of our angle is negative, right? The sine of our angle is negative. So that angle can't be in the first quadrant. So let's get rid of that. And now we know that our angle must be in the fourth quadrant. So to recap quickly, we determined what quadrant this angle would lie in by using the range of arcsine that helped us rule out quadrant 2 and quadrant 3, and also by our knowledge of the signs of each of the trig functions. We knew that the sine of our angle has to be negative, so that ruled out the fourth quadrant, so our angle must be in the fourth quadrant. Next, we take a look at our reference angle. Okay, we looked at that, now we're looking at reference angle. So what angle has a sine of 1/2? Well, you know that that would have to be pi over 6. So here is our last step. Our reference angle, this has to measure pi over 6, but we need that angle to be in the fourth quadrant and between negative pi over 2 and pi over 2. So that angle would be negative pi over 6. Okay, because negative pi over 6 is in the fourth quadrant and has a reference angle of positive pi over 6. So again, first you determine the quadrant in which your angle must lie. You find your reference angle, and then determine what angle in that quadrant has that reference angle. All right, let's try another one. Let's stick with sine for a moment. Inverse sine of radical 3 over 2. So again, this is saying that the sine of some angle is radical 3 over 2. Now there are infinitely many angles whose sine is radical 3 over 2. We have to find the one that is in the range of arcsine. So remember the range is this. So here's negative pi over 2, here's positive pi over 2. All of the angles in between would be either in the fourth or the first quadrant. So we can rule out these two quadrants. Then notice here that sine of the angle is a positive number. Sine is positive in the first quadrant, but negative in the fourth. So we're ruling out the fourth quadrant. So here, our angle must be here. Now, let's think about the reference angle. So what acute angle has a sine of radical 3 over 2? Well, we know that that has to be pi over 3. So our reference angle is pi over 3. So now we put these two ideas together. We need an angle in the first quadrant that has a reference angle of pi over 3. And I kind of like this problem because pi over 3 is already in the first quadrant and is between negative 90 and 90 degrees. So that's our answer. Okay, let's try inverse cos here. Let's do arc cos of radical 2 over 2. Now the range for inverse cos is a little different than it is for inverse sine. That's from 0 to pi. So angles that are between 0 and pi radians would be in the first or the second quadrant. So let's rule out quadrant 3 and quadrant 4. And then we know all of our trig functions are positive in the first quadrant. Sine is positive in the second. And if you look here, this is a positive value, so we want our cosine to be positive. That's not happening in the second quadrant, so we're ruling that out. So our angle must be in the first quadrant. Next, we look for our reference angle. And remember, we're thinking that the cosine of some angle is radical 2 over 2. Well, we know that that has to be pi over 4. And pi over 4 is already in the first quadrant. Pi over 4 is between 0 and pi. So that's our answer here. Arc cos radical 2 over 2 is equal to pi over 4. Okay, I'm going to change something here. We're still going to look at inverse cos, but sometimes you're going to encounter problems that involve using the unit circle. So I'm going to draw that on the side here. So we've got 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay. So this question here, we want to know, when is cosine equal to negative 1? Well, we know that that's going to happen over here, when our x value is equal to negative 1. So that looks like pi radians. And that is in our range. Remember that the range is 0 to pi. So that means that the arc cos of negative 1 is equal to pi. Okay, one more with the unit circle. Let's change this to tangent. The inverse tan of 0. Well, where is tan equal to 0? Well, that's going to happen where our y is equal to 0, right? So it's going to happen either at 0 or at pi. But it can't be both. So we're going to remember that our range for tangent is negative pi over 2 to pi over 2. Now 0 is between negative pi over 2 and pi over 2, but pi is not. So that means that the arctan of 0 is equal to 0. So to summarize, what you do first is you determine the quadrant in which your angle lies. You're using two pieces of information for that. One of those would be the range of the inverse function and then the sign of the value that they've given you. After that, you determine your reference angle, and then step 3 is the big one. You put steps 1 and 2 together, and you find the angle that has the reference angle from step 2 and that lies in the quadrant from step 1. Always be sure that your final answer is in the range of the inverse function, and that every once in a while one of the angles is going to be quadrantal, in which case you are using the unit circle. Now, if you find that these problems are giving you any trouble, what you want to do is go back and practice evaluating trig functions. You need to be able to do these well in order to do them backwards. So if you need more practice, go back to our blog, download one of the practice sheets, and see me with any questions.